Infrastructure as code, also known as IAC, is the managing and provisioning of infrastructure through code instead of manual processes. It allows you to define resources with code, from a simple database table to a very complex architecture. It offers fast, reliable, and consistent way for developers to define the resources they need, fastening the development lifecycle. It also prevents wrong manual configuration, configuration loss, and differences between environments due to human mistake. Infrastructure as code started with declarative files, often written in YAML. This video is about a specific kind of infrastructure as code, the new generation, which is using a set of programming languages instead of a simple declarative definitions file, with new tools like Pulumi, Terraform CDK, AWS CDK, or CDKtf. The languages you can use with those new tools are TypeScript, Python, Go, C# or Java. Using those languages prevents schema errors or indentation mistakes like you could have in a YAML file. You can use the full power of a programming language for specific needs like conditional resources allocation, or easily save it and revert it in a Git repository. Pulumi and Terraform are universal, meaning that you can use them to set resources in any cloud. AWS CDK is only for AWS Cloud, and CDKtf is specific for defining Kubernetes resources. Those new tools offer much more possibilities. You can use simple definition of resources or use high-level components that pre-configure multiple resources with proven defaults. If you are using Terraform CDK, AWS CDK, or CDKtf, you can find high-level construct on the Construct Hub website. On this website, the official providers or the community can share out-of-the-box solutions for your needs. For instance, if you are willing to use Databricks solutions, you can browse here the different constructs available and use their solution, which will set the whole infrastructure you need. For the following example, you will need AWS CLI, Node.js NPM, Go, and set an AWS default profile. Once it's done, install AWS CDK by running the following command in your terminal. Let's start by setting a simple HTTP server. We create the folder and initiate a Go module. Then we create a simple package. In the main function we define a simple ping-pong route and we tell the server which port to listen. In order to containerize the server, we will set a simple Docker file. For this, I will copy the distroless example provided by Google in this GitHub repository. We are now done with the HTTP server and we will set the infrastructure for deployment. Let's create an infra folder and initialize a CDK app. The infra.go file is the main entry of our infrastructure. We will define here the stacks and the resources we want. In this example, we will use the AWS Service App Runner, which is a fully managed container native service with load balancer, TLS, and auto-scaling. First, let's add the construct dependency by running go-get. Then, let's set a new app runner service. For each resources you set, you first need to indicate in which stack you wish to place the resource, give it an ID, and then pass the properties. Let's set the source property, which will be the Docker file. We tell CDK where this Docker file is located. Then, we pass the port we've set previously in the image configuration. Afterwards, let's print the URL of our service in the terminal in order to test it. And that's all. Let's deploy with the command cdkdeploy and wait for our configuration to be sent to the cloud and for the resources to be set. We copy the URL printed and we send a HTTP request. Your server is now deployed and ready to be used. No matter the size of the project you are working on, always privilege an IAC solution. It is faster and more stable. If you like the video, please like and subscribe.